All right, so hello and welcome to this uh to another lecture series. My name is Chibuzzor Marcel, and I'm the director of the Pan-African Citizen Science E-Lab. So today we are going to be learning about star clusters. What are star clusters? So in the table of contents, I shall be introducing star clusters, and I will then revisit a question that I asked during my last lecture in binary stars. I'm going to answer that question. Remember, I asked, do multiple star systems tend to become star clusters? Okay, I'm going to answer it here because we are dealing with star clusters. Then I'll go forward to explain, to talk about types of star clusters, life cycle of star clusters. Then star clusters and constellation, I'm going to talk about that difference, if they are different or the same thing. Then I'll talk about habitability in star clusters, if it is possible to find life in a star cluster. So what is a star cluster? Star clusters are groups of stars that are gravitationally bound and formed from the same molecular cloud and share a common origin. I said star clusters are groups of stars that are gravitationally bound and formed from the same molecular cloud and share a common origin. Now, star clusters coexist in the same volume of space, and they are approximately born at the same time. What do I mean by these two statements? I will revisit them when we come back to it. So here is a picture of the sky showing some stars, okay? Now, if you observe these pictures very well, you will see there are some regions where some stars cluster together, okay? Look at this region. Stars cluster around here, okay? There are also some stars around here. So if you compare this region to other regions here, you would, agree with me that here is called a star cluster. So here is called a star cluster. So here is another kind of star cluster. Okay. Now, this is exactly what I mean by. So anytime you identify star clusters, these two things should come into mind. They coexist at the same volume of space, and they are born approximately at the same time. These other stars that you hear that are here may not be in the same volume of space. They can be at different places, different locations. Remember what I talked about, physical double stars. Physical double stars are chance alignment of stars. They probably do not have any relationship. Okay, so that's exactly what I mean by that. So for star clusters, if you identify star clusters, they are born approximately at the same time. Okay, they could just differ by some, say, few million years. Okay, so that's exactly what I mean by that. So here are some examples of star clusters. The Hades star clusters, Alpha Persei cluster, Pleiades, Coma star cluster, Southern. This is Southern Pleiades, and so on and so forth. So here are some examples. These are just examples of some known star clusters. So now, do multiple star systems tend to become star clusters? And the answer is yes. Star clusters are advanced multiple star systems. I mean, star clusters are advanced double star and multiple star system. So if you look at this picture, let me reverse back to this picture, to this simulation. You see two stars that are orbiting about a common center of mass. Okay, let me play this video from the beginning. These two stars are orbiting about a common center of mass that is located where my mouse is right now. Okay. Now, one thing about this double star system is, one thing about this common center of mass, there's nothing there, just an empty space, but they are responding to that empty space. So the reason why I said you should pay attention to this is because when I come into explaining star clusters, you have an idea of what I'm talking about. Because for star clusters, they behave in the same way. They revolve about a center of mass that has nothing in there. Okay, so I wanted to just pay attention to that. So let me show you other examples. So here is a double stars, two star systems. So here you have three star systems. This is the Proxima Centauri, the closest star system to us. So here is four star systems. This is the line of motion of their centers of masses. So here is five star systems. So this is how we have 5-star systems, 6-star systems, 7-star systems, and so on and so forth. So the reason why I'm showing you this again, because I showed you this video simulation during my last lecture, is because I want to prove to you that star clusters are advanced level of double star and multiple star systems. So types of star clusters. So we have open star clusters and we have globular star clusters. So here's an example of these two types of star clusters. So here's an example of an open star cluster. So this is NGC 6124. You can see some stars that are clustered in a particular location. But what makes it an open star cluster? So one of the things that makes it an open star cluster is that the stars are not too close to each other. The stars are not too close to each other. What do I mean by the stars are not too close to each other? If you look at this picture, you would see that the stars are actually very close. But if you compare the stars in an open star cluster to those in the globular star cluster, you agree with me that the ones in the globular star clusters are much closer. So when I'm saying that the stars are not too close, with the closeness of the stars in the globular star clusters. So for stars in open star clusters, they are not too close to each other. Now, there are about 1 to 10 stars per cubic light year, like in a volume of space. We are using light year, okay? We have about 1 to 10 stars per cubic light year, okay? So remember, the closest star system to us, the Alpha Centauri system, is about 4 light years away. So, so now imagine 1 light year. So 1 light year in length, height, and breadth, okay? So that is just a volume, okay? So imagine in a cubic light year, you fit in about 10 stars. So that is a lot of stars, right? A lot of stars in that given volume. So that is exactly what we mean by that. We are comparing it with that of the globular clusters. So again, the stars are loosely bound by gravity relative to the global star clusters because they are not too close to each other. So it makes a lot of sense. They are loosely bound by gravity. So they typically contains a few dozen to a few thousand stars. A few dozen to a few thousand stars. And if you look at the open star clusters, they do not seem to have a definite shape. So here's another example of an open star cluster called the Pleiades. The Pleiades. So still on the features of the open star clusters. Now, open star clusters are dominated by hot blue stars. They are dominated by hot blue stars, okay? Remember what I talked about stars that are blue in color. It means they are very massive because their mass, the light they give out actually show their size. For the low mass stars, they give out red. For the high mass stars, they give out the blue color. Okay, so for the blue stars, they give out for the stars in the open star cluster, they give out this blue light. They are mostly blue. The lights are usually blue. So you can even see that from the global, from the Pleiades. Now the stars are relatively very young, ranging from a few millions to a few billion years old. Okay, they are very, very young. That is where, in the open star clusters, is where you find the youngest of the stars. That is where stars are even born. Okay, so that is where you find stars that are up to 1 million years, 2 million years. These are very young stars compared to the typical ages of stars. Remember, or even the typical age of the universe. So if you have a star of 1 million, 2 million years old, they are very, very young. They are still in their infant age, in their infant stage. So that is where you can even see new stars that are being born right now. So in case if you're an astrophysicist and you're interested in studying those kind of stars, you have to look at open star clusters. Now, from statistics, 50% of the stars, 50% of the stars in an open star cluster are less than, sorry, 50% of all known open star clusters are less than 200 million years old, which is the same, very young. They are very young. They are very, very young. Now, only 2% of them are over 1 billion years. Only 2% of them, but most majority of them are just 50%. Now, over time, the stars in an open star cluster disperse due to gravitational interaction with other star clusters, because they're not only star clusters, or even the tidal force from the center of the galaxy. So here is an artistic picture of our Milky Way galaxy. This is not a real picture, but an artistic picture. Now, these open star clusters are located in the plane or in the spiral arms of our Milky Way galaxy. So here is the picture of our Milky Way galaxy. Here is the galactic bulge, and here is the spiral arms. So at these spiral arms are places where you can find these open star clusters. In these spiral arms are where you can find these open star clusters. So here is another example of an open star cluster, the Carina Nebula. This image was taken from the James Webb Space Telescope. So even there are some stars that are being formed in this cocoon that you cannot see with an ordinary telescope, except to use something like the James Webb Space Telescope, and probably the Hubble Space Telescope. Okay, so the entire system is an open star cluster. Now, for the individual stars, their typical mass is about 50 solar masses. 50 solar masses, that is 50 times the mass of the sun. So they are incredibly very, very huge, very massive. So, and these are classified as high mass stars. Now, the size in terms of diameter of these open star clusters is about typical 15 light years, 15 light years across. So, and so far we have discovered up to 1,200 open star clusters, 1,200 open star clusters. So now I want to show you the largest open star cluster that has been discovered. It is called NGC 6791. It is located in the constellation Lyra, and it's about 13,300 light years away from Earth. The age of this open star cluster is about 8 billion years. 8 billion years. Okay, it's just among the 2% that are above 2% that are above 1 billion years, like I told you before. And it has around 10,000 stars, and it's about 13,000 light years in diameter. So here is the cluster here. This is a zoomed out picture of the open star cluster. Now here is a zoomed in open star cluster. If you zoom in, you see some stars that are blue and red. The ones that are red are those ones that have evolved past the main sequence stage. They are in their red giant phase. So here is the smallest open star cluster called IC4665. Okay, it is about 1,100 light years away from Earth, and it is just 55 million years old. It has around 30 to 50 stars in it. It is about 15 light years in diameter. So the sun was once part of a young open star cluster where it formed alongside many other stars. But over time, the cluster dispersed and the star became solitary star we see today in the galaxy. So our sun used to be part of an open star cluster, but it is no longer. So if you look around, it's no longer part of any cluster anymore because it has been dragged out from that cluster. In fact, we can not even trace that cluster. That cluster may not even be existing today. They have probably evaporated. Then here we have a globular star cluster. This is M5. This image was taken from our lab. We used the Los Comet Observatory to take image of this star cluster. Of course, we did a color combination to produce this image. So it's an open star cluster. So it is the stars are very close to each other, okay? They are very close to each other. So if you can observe it, they are very, very close to each other. So, and the overall shape of these globular star clusters is that they are spherical in shape, okay? They are spherical in shape with stars densely packed towards the center. The sort of densely packed toward the center and loosely distributed in the outer regions, as you can see it from this picture. Now, the average star density in a globular star cluster is just 25. So remember, for the open star cluster, I said about 1 to 10, but for a global, it is just minimum of 25. Minimum of just 25 stars per cubic light year. So that's a lot of stars. Now, if you want to know the distance from one star to the other, the distance you can move from one star to the other. If you are measuring it from the core, distance is about 0.1 to 0.5 light year within the cluster. But outer region is about 1 to 2 light years. Okay, so the stars are tightly bound by gravity. They are tightly bound by gravity, and they do not interact much because of their location. So here's another example of a globular star cluster. This is M13. Okay, the stars are smaller, okay, red and dim. Sorry, this picture is looking white, okay, but in reality the stars are red. The reason is because of the color combination during the image processing of this M13 image, okay, but the stars are very small, okay. They are just about 0.8 solar masses, just the size of our sun. So I remember small stars give out red light, so they are red in color. Okay, but because of their sheer number, they are very much in number, about 10,000 to about 1 million. Okay, they range from 10,000 to 1 million, so that is why they can even be observed. If they were the numbers of open star clusters, we probably may not be able to notice them, probably. Now, their age, they are very, very old. They range from about 10 to 12 billion years. So that is almost compared to the age of the universe. And that is not even surprising because if you look at them, they look so compact. So it makes a lot of sense. They were formed during the time the universe was still expanding. So that is where you find these population 2 stars. Population 2 stars are metal poor stars. So here is an artistic picture of a Milky Way galaxy edge on. So, and I want to show you the location of these globular clusters and even the open star clusters again. So here is the galactic bulge, the center of our galaxy, and here is the open star cluster. So here is the spiral arms. That is where you can locate the open star clusters. And here is the galactic halo. And that is where you can locate the globular star clusters. Okay. Now, one thing I want you to know here is that for the open star cluster, they move with the flow of the spiral arms. So if the galaxy is moving in this direction, everything is moving in that direction, okay? Assuming that the galaxy is moving in like my mouse, or maybe like this, okay? So everything, all the stars, even the open star clusters are moving in that fashion. But that is not the way global star clusters move. They hover about the galaxy. They hover and they move in different directions. This particular star could be moving like this one could be moving like this one could be moving in different directions. Even the stars within them move in different directions. Okay, so this global cluster, the only relationship it has with our galaxy is that our Milky Way galaxy has attracted it with its own gravity. So, but still, they are doing their own thing. So this one could move like this, can penetrate the spiral arms and come towards this direction and continue moving. This one can move like this. They are just move in different directions. So we have also discovered some global clusters in the spiral arms. And the reason why that is so is because they are just passing through the disk. So here is another example of a global star cluster, NGC 6934. So the size in terms of diameter of global clusters is around 10 to 300 light years across. So now these global clusters, they spin very low. They do not spin that much. Their spin rate is much less than the spin rate of planets in our solar system. So they do not spin much. So far we have discovered up to 150 global star clusters. So these global star clusters are homes to these black holes, neutron stars, and white dwarfs that were treated in the past. Remember, these are remnants of massive stars, and massive stars do not live that much. They do not live long before they turn into these black holes, neutron stars, and white dwarfs. So if you look at global clusters, you're going to find a lot of these dead stars. So global clusters are home to the kind of variable stars we call RR11 stars. RR11 stars. That is where you can locate them. Variable stars are stars that change in their brightness. They twinkle like they're being in change of that. They're like twinkling stars. Okay, I'm not saying that the stars that twinkle at night are global clusters, are RR11 stars or variable stars. No. Okay, the reason why stars twinkle at night is because of our atmosphere. But these stars, naturally, in their natural state, they change in their brightness. We call that variable stars. And other stars are one of these stars. And one of the most important use of these stars is because we use it for standard candles. We use it to measure distances in the universe. So you can see how these stars are twinkling. So these are global star clusters. So now, if you look at global star clusters, like I told you before, they are dominated by red dim stars. But from our observation, we have also seen some blue, gigantic stars. Why are they there? So, and they are much younger. Why are they there? So this thing used to be a mystery. Imagine you having young stars among ancient stars. So that was a mystery before we discovered what was happening. So what was happening is because these stars, they collide with themselves. Okay, when two stars collide, their mass will increase. Okay, and that will overall change the star evolution. So let me show you what I mean by that. Remember what I told you about the motion of stars in a global star cluster? The stars are moving in different directions, and when that is happening, they are colliding with themselves. Yes, they have their orbits about a center of mass, like I told you before, but over time they collide, and that will make their mass to increase. So their mass could increase from whatever it is to the size of a massive star that could give out blue light. So this is exactly what is happening with these globular star clusters. I don't want to show you everything because of time. So we also have globular clusters in other galaxies. This is the Sun galaxy. So all the stars, all the light dots surrounding it are globular star clusters. Okay, so they are globular star clusters. All these lights. Some of these lights are from our galaxy. Okay, like this one is from the Milky Way galaxy because that's why you have those spikes. Some other dots are from other galaxies, but these they are labeled. Okay, I don't think you can see them, but they are labeled. They are labeled here. So how are star clusters formed? Life cycle of star clusters. So for a star to start forming, there must be a trigger. Maybe it could be from a supernova explosion from an older star that have lived out its life. So the shock wave travels and slams on the cocoon, the nebulae, and the nebula is going to collapse and stars will begin to form. Observe that the stars are forming at different times, corresponding to what I was talking about. It could vary by some few million years, for some few million years. So let me show you this simulation in a more advanced form. So here is the collapse of the giant molecular cloud, probably triggered by the supernova explosion that I just showed you right now. Now you can see two color variation. We have region of that is red, and we have region that is yellow. The yellow region is region of high pressures and temperatures where stars are forming. So you can see the stars are beginning to crystal out. So that is exactly how stars and star clusters are formed. So exactly, so as they are formed, so you have a lot of them. So like I told you, star clusters from same cluster, okay, stars from same cluster have the same age, metallicity, and chemical composition. That makes a lot of sense. Stars from the same cluster have the same age, metallicity, and chemical composition. So here is a 3D depiction of the star cluster. It's a 3D depiction of the star cluster. Showing that makes a lot of sense now. So that is how clusters are formed, whether it is an open star cluster or a globular star cluster. So stars in a cluster orbit about a center of mass, which can be an empty space. You know, remember what I told you about double stars and multiple star system? They orbit about a center of mass that is an empty space. There mustn't be anything there. So they are equally contributing to that mass, to that center of mass. Okay, there's nothing there. So that is unlike our planets. You know, the planets are orbiting about the sun. The sun is providing the gravity at which they are. The sun is providing the gravitational force. Okay, even our galaxy, the Milky Way galaxy, they are orbiting about the black hole at the center. So star clusters are different from those systems in that they do not have anything at the center that they are responding to. Rather, they are contributing to that center of mass. They are individually contributing to that center of mass. So that's exactly what is happening. So here you have two stars. The blue one is more massive star, and the red one is the less massive star. I want to show you how stars are tossed out. Now, this is a star cluster, but we are using two stars as to simplify the model. So here you have a red star, which is less massive, and here is a blue star, which is more massive. Okay, from what I've told you before, the center of mass will be closer to the blue star. However, they are exchanging potential, that's changing energy. Okay, so the one of the blue star is going to be tossed away. That's exactly how stars are lost. So stars clusters can lose stars, and that process is called evaporation. So, and this is due to gravitational interaction with nearby stars. Now, in doing that, in the star clusters, the less massive stars are tossed away first. Even if you have double stars that has planets in it, okay, just like you have in a three-body problem, the movie called the three-body problem, you see that the orbit of their planet cannot be predicted, okay, because of this issue. So the less massive one is tossed out, just like the planet is going to be tossed out. So if you're having stars, the less massive stars are going to be tossed out of the system, leaving behind the more massive ones. So the solution of clusters is faster in open star clusters than in globular star clusters. And that makes a lot of sense because, first of all, in open star clusters, they are loosely bound by gravity and they are located in the galactic disks. So there is interaction with other clusters and other systems, even the tidal force from the center of the Milky Way galaxy. So, but if you compare that with globular clusters, they do not interact with anything. So that is why the solution of stars, the evaporation of stars is more rapid in open star clusters than in globular star clusters. So I'm going to talk about star clusters and constellation. What is the difference between star clusters and constellation? What is the difference between star clusters and constellation? Star clusters are physically connected groups of stars, and we have seen that. They are physically connected groups of stars that have a shared origin and gravitationally bound, okay? While constellations are visual patterns made by stars that may be far apart and do not represent any physical relationship. An example is this Orion Nebulae. This is just a chance alignment of stars that gave out a pattern, okay? Chance alignment. So, but even within that Orion constellation, you have the Pleiades, which is a star cluster. So they are not the same. They are not the same. For star cluster, there is a relationship between these stars, but for the constellation, there is no relationship, just a chance alignment of stars. Is it possible to find life forms in stars, in star clusters? Is it possible? Like I told you from the three-body problem, it is hard for a planet to survive there. So because of the gravitational interactions among nearby stars, it is going to be very hard for a planet that will sustain life to stay there, okay, because of this constant gravitational interaction. And orbit cannot be predicted. Okay, the next orbit of the revolution of the planet cannot be predicted. So it is very, very unlikely that life forms could live to survive in an open star cluster. So the radiation levels from multiple stars, from other stars, due to intense radiation and even possible supernova explosion, could make life forms very hard to be sustained. And also there is a problem of metallicity. Okay, problem of metallicity. For global star clusters, they are mostly dominated by population 2 stars, which are metal poor stars. Okay, and metallicity simply means those elements that are above hydrogen and helium in the periodic table. Okay, so where those kind of stuff are formed are around population 1 stars. Okay, so if you do not have, since there are stars around global clusters are of poor metal, it is likely that you may not find any planet in a global star cluster. Probably. I'm not saying you must not. Probably you may likely not find. So that will bring me to the end of my lecture. That will bring me to the end of my lecture. So thank you so much. You can ask me questions.
Thank you. Thank you so much. So, if you have any question, just write in the box. Okay.
Yeah, you can put your questions in the comment section.
Yes,
I'm going to respond to them.
Yes, even in the YouTube channel.
Yeah, exactly.
Okay. So have a nice day. wait, wait, wait.